Cameron Purdy piles in this go around. Hello. Okay, so this is Coffee Compiler Club. I'm starting the camera now because it's way past time and we have several people trying to join who can't figure out how to do it. I'm going to take them off the technical excuse list. You're recorded live. This will all go on Twitter in the next day or week. If you don't like that, bail out. Anything to do with compilers, concurrency, language runtimes, concurrent skip lists are all fair game. I reserved right to moderate, never had to do it. And we were just having a conversation about concurrent skip lists, and I put it on hold for a second so that let's carry on. So Cameron, tell me again about concurrent skip lists.
Yeah, so basically it's a balanced tree. So in a balanced tree, you figure every leg of the tree, every branch you can take from the root of the tree to the leaf nodes will have roughly the same number of steps. Like red-black tree, it could be off by a factor of 2.
Right.
But the idea is it somehow magically balances itself, right? So take a binary, take a red-black tree, for example. Like most people have a hard time understanding red-black tree because they think of it as a binary tree when it's not. It's actually a B tree. It's a 2, 3, 4 B tree.
Yeah.
So basically it's a B tree whose nodes can have up to 4 elements, right? 4, yes. And so basically what they did is they said, okay, if we have a 4-element B tree node, we're going to map that to 3 binary tree nodes.
Mm-hmm.
So one node keeps a pointer to 2 nodes. Those 2 nodes keep a pointer each to 2 leaves. That gives me 4 leaves.
Yeah.
Right. And so kind of worst case scenario, I could have that same thing, but only 2 leaves instead of 4. So I could drop 2 of the leaves. So I still have that same balanced structure, but only 2 leaf nodes, right?
Right.
Or I could have 3 leaf nodes. So that's what's a 2, 3, 4 B tree. But anyway, so basically the red-black is just a Boolean flag that says, I'm the one that only points to nodes below me, or I'm the one that's a leaf node, right? So basically it allows you to represent in a single bit whether you're the top of that triangle or the bottom of that triangle. Pretty cool data structure, but what the skip list does is it takes a balanced binary tree and it turns it 45 degrees, right? So take a tree, right?
Yeah.
And now turn it.
Yeah, I get it, I think.
Right?
Right.
But now each of the you could think of it as, as divide and conquer. You're always dividing by 2, which is what gives you the logarithmic access speed. But instead of like keeping track of the balance so it can rebalance itself dynamically, what it does is it randomly picks the number of pointers on any one node to the next node. So let's say it's a 32. If you look up algorithms, they're mostly done in 32-bit. So you have 31 pointers on your head node.
Mm-hmm.
And the idea is that the 31th will point halfway into the list if you have 4 billion items,
mm-hmm. Mm-hmm.
right? 2 to the 32nd, right? And your 30th will point 1 billion into the list, and that'll point to the 2 billion, and that'll point to the 3 billion, right? But instead of actually structuring it and maintaining data that allows it to keep that balance, it just randomly picks it coin flips is what Bill Pugh called it. It coin flips to determine the height of each node. And the result is actually startlingly close to a balanced binary tree. It's pretty cool.
Okay, now why is this faster than a hash table?
Oh, it's only faster than a hash table if, well, okay.
And a hash table is not ordered, and you said ordered, which is a
right. This is the fastest ordered structure I've found that allows you to have random points of insertion and deletion.
Okay, fine.
With good speed on access and insertion and deletion.
It's like a doubly linked list starting through a hash table might have something similar.
Right, and hash table generally is very fast until you have a bad hash function. So. That's
Yeah, I went round and round that because I was the firm believer that, you didn't need to do too much with the hash until I got burned enough times.
yeah.
And now I do what Doug Lee does, which is I put 3 clock cycles of a hash spreader on whatever user mode hash you give me. And it's really hard to defeat the hash spreader unless you have algorithmically reverse engineered my spreader. So yeah, I just generally get good.
So back to the concurrency aspect of it. So we had originally implemented a red-black tree, which of course is notorious for not being terribly good for concurrency purposes.
Yeah.
But we replaced the red-black. This is years ago. We replaced it with an AVL tree, which was pretty good. But then for concurrency, we replaced it with a skip list. So concurrent. So if you do Google on concurrent skip lists, you can find some pretty good.
Yeah, I looked at them years ago. I had just forgotten about them. But if you need order and random insertion, then maybe there's more of an argument. I rarely need order.
Yeah, and they can be very compact too, which is handy. So the one I've actually implemented on top of an array to optimize for cache line.
Yeah. In hash tables, I use, I guess, open instead of closed hash for the same reason. That's fine.
Well, open instead of linked, right?
Mm-hmm. However you want to call it, open. Yes. But it's the same goal, is to
much kinder to the memory subsystem.
Yeah. Okay. We are missing. The guy asked a question last week and we ended on. Simon. Simon's not here. Okay, fine.
He will probably join at 8. To me at 8. So I don't know what time is it.
I have at 10 o'clock for me.
Here is 7 p.m. Okay.
Okay, so you think he'll join in an hour or something?
Yeah. He'll probably join at 10 at the specified time.
Okay, fine. Cole, why are you here? What are you doing with compilers?
I'm kind of adjacent to compilers. I am writing a little compiler for WebAssembly, but I'm actually I do kind of like a closure-like data structure library in Rust. But I love compilers. I've seen a lot of your work, and I just enjoy hearing about people talking about these things. So
this is like persistent data structures in Rust?
Persistent data structures, yeah. They're kind of the analogous to the closure transients, but they're using, instead of a garbage collector, instead of a Java sweeping garbage collector, it's using reference counting. So otherwise analogous though. But the little WebAssembly compiler is kind of neat. WebAssembly is kind of just like a cool little sandbox. So I'm having fun with it. Yep. Thanks for inviting me. I really appreciate it, guys.
It's okay. Mostly my bar is like really low. I ask you what your interest in compilers is, and if you bail out, then you're a porn bot.
Mm-hmm.
And otherwise, I let you in.
Nice.
That's the bar.
Yeah.
I
actually had a random question. If nobody has anything right now.
Yeah, fire away.
Cliff, I saw a presentation you did a couple of years ago, and you mentioned with the hardware transactional memory you were talking about.
Yeah.
And you were saying that you made a simulator, and you were saying the simulator actually had an interesting way of kind of detecting race conditions.
Yeah, it was the best race detector I ever saw.
Yeah, I would be kind of curious because I've kind of heard about like the Go race detector, and I kind of did some work, kind of like chess-like work. If you're familiar with the chess tool, just kind of simulating.
I did one of my early parallel talks was doing making a model checker, and I thought it was related to chess, but it might have predated it. Go fast, go 400-way parallel on an Azul box.
Nice. Well, I'd be kind of curious because, like I said, I've kind of done like a little chess thing to try and make sure that my data structure implementations are thread safe.
Okay. So This is almost surely a spam call because that's all I get from unknown numbers. Yeah. So so the context here is that I'm writing a simulator to run Azul hardware on an x86, and we want to have at least a little parallelism. So we have 4-way x86 back in the day, so we're going to be 4-way parallel, and we're expecting to have data races. And I just come from Sun, and I had done a lot of data race work at Sun on Spark and x86, and then was doing some Itanium stuff, and I'd walked away, but the Itanium runtime was full of data races. So, I was going back and forth with, oh my God, I can't remember his name now, Steve Goldman, who's dead now, unfortunately, on data races in the Itanium set. And I was staring at the simulator and realized that I had had 3/4 of the way there. So what I get out of this thing is a 10x slowdown over running the real hardware because you're running on a simulator, and that's kind of common for data race detectors. And then after that, it was highly reliable. So the loads and stores. So the rule was if you wrote to a memory location that you read from without a fencing operation, that was considered a probable data race. So you wanted to track all the loads and stores and fences in some cheapest possible way. And then some of the data races were known benign, and you would just have a table of known benign races that you extended slowly over time, and you just tagged them as benign, and next time around it would just let it fly. So what it did was it kept the last 1,000 addresses in an open hash table that you never bothered to even reprobe in. So you took an address, you probed it into the hash table, and if there was somebody else had done a store there, you declared a fence issue, you declared a bug. And then if you, and otherwise you just tagged it as I read here. And if a store came along and he looked and saw the other direction, whatever, he declared an error. And on a fence, you cleared the table. Except that we didn't even go that far. We just like how do we do this thing? We kept the last 1,000 stores. I have to go pull up the old docs. I had a way to do this in a clock cycle for every operation. Like loads and stores were 2 or 3 clocks to probe because there's no reprobing, and you just took the low bits of the address, a little spreader on the address, probe the table, and you didn't reprobe. And on the I go pull the thing up, and then on the clear, we didn't want to clear 1,000 element hash table, but we picked it out of 1,000 elements. The end result was we would sort of extremely reliably find data races in one pass. It was all deterministic. So you would repeat it and you get the same data race every time. And then you could go through and say, here's the load, here's the store. You had the load in the store or the load in the fence or whatever. You had all the last set of things, and you had to go track it backwards. And the program counter they came from, that was the program counter they came from was part of that story. And you could track back to where it came from. Let me go find this stupid thing. I'm missing some key bit, and it's been a while. This is like a really old thing. I was at Azul. This is the Azul. Now that's the Azul general talks. GC. Yeah, this is my fun testing concurrent code. Oh, debug tools. This is gonna be the old one. This will be good enough. I can throw this in chat here. Multi-core tools, multi-core simulator. All kinds of cool shit. Like you have to use a Spark CAS instruction to mimic in your simulator, or an x86 CAS instruction to mimic a CAS in the system under test, because you actually have to have atomicity if you have multiple cores running in the simulator, and there's no way to fake it in the simulation code. You actually have to run a CAS. It's pretty slick.
Sure.
And then a data race detector, that's what I'm looking for. Okay, how do you guys want to hand the slides out here? I got to figure that one out here. Nearly infinite store buffer. Okay. So I'm simulating a nearly infinite store buffer. So I keep the store addresses. Yeah, okay. So I keep the store addresses as if I was a store buffer, and I throw them in a ring buffer, and that takes like 3 more clocks besides just doing the store in the simulation. And a clear is you just reset the ring buffer to its current size. And a load looks for a hit because you have a second hash table besides the ring buffer. Okay. And if you go get a hit in the hash table, which you often do, you always do, you go back to your ring buffer and find the matching hit. And if it hasn't been fenced, you're dead or not. And that's the hack. Okay, so let me go. I have all kind of cool pictures and code and stuff. Let me figure out. Can I throw a file on chat here? How do I send a PDF out? I wonder if I can PDF on Twitter. File. Dropbox. We can Dropbox. That's the hard way to do it. Let me see if they'll do drag and drop here. No, I have to do a Dropbox account. This is getting slow. And very slow for Google to sign in, Google Dropbox to sign in. Hello. Well, you know, whatever, fine. I'll throw it out on Twitter if I don't get it linked here in a second. I hit the sign in button on Dropbox and it like is stuck in an infinite spin cycle. This is weird. Like usually you would say yay or nay right away. And we make sure all links, in fact, for Dropbox, everything's enabled. Hit the sign in and it just spins forever. So Dropbox is toast. I don't know why. Fine, that's annoying. I can screen share, but I don't know if you guys want to go down that path, whatever.
I think it's fine.
Yeah, fine. Let me do this with screen share. Okay, so is this visible here? Data race detector. I'm in the middle of a talk, so I've skipped the simulator in general. Fast mode was the one where we were only some X slower than like we thought the real hardware turned out to be. So what we go do here is we make a nearly infinite store buffer, which simulate like a store buffer on a real piece of hardware just pins stores until the memory can take it. And you would pin the stores until you hit a memory barrier, and then you flush them all. So it's as if your CPU is running as far ahead as it possibly can, ignoring its ability to write to memory because it's pretending it's too fast and memory bandwidth is sucked up, until you hit a fence, and then it stalls and writes all the stores out all at once. And the theory is if a load would hit or a store would hit, then you had a memory, you had an unfenced data race, and you had to deal with this. Okay. So I just need the addresses. So the data in the store, I actually do write out right away, independent of a store buffer. So they actually get written, so I don't have to hang on to the data. And then I want to hang on to the addresses, pretending that I didn't write them out. So I just have a big old ring buffer. And because the statistical ring buffer is a fixed size, so I just bump it forward and pound it down. And because it's a ring buffer, I can zap it to empty in a clock cycle. Fine. Then when I come to a load, I want to ask the question, am I hitting an address that's in my store buffer? So I guess go to this global hash. I probe the table looking for a hit, and it's lossy good enough. And I'm trying to see if the store hits I guess I'm looking at a store hits a load in the table. Yeah, I'm taking the store address and looking up what CPU and what PC. Where's the PC storing here? I swear I stored the PC. The load is looking in the table, so the stores are in the table. Oh, you have the PC on the load right away. I know I stored the store has to store into the table in the ring buffer. The load only probes the hash. The store stores it twice. So my slowdown over simulation was about 10%. So I'm still getting 130. This is an old hardware. This is a decade old x86 hardware. So 130 megahertz was the effective clock rate in the end. And I found the reason I brought up Steve Goldman is I kept finding data races in the original hotspot on an x86 that were actual real data races, even on an x86, but there were plenty on weaker hardware. So Itanium had the same weak hardware as Azul did. And so we kept finding Itanium data races as well. So, I about every other day I came up with a data race. I went to Steve Goldman, and every other day he had a data race on the Itanium, and we kept swapping data races back and forth for a period of 3 or 4 months till we got things, locked down. Eventually got to the point where I could launch JBoss under simulation, which is a sort of a pretty heavyweight Java app. Yeah, fine.
To say the least.
Yeah. We had to run it in slow mode to boot the OS, but we could boot the OS in the simulation in slow mode. And slow mode included like TLB hits and misses and every possible hardware idiosyncrasy. Fast mode was just for running x86, just running Java. And included the JET. Now the JET was GCC spitting out Azul hardware instructions, which then were simulated. But we faked our way forward. The other fun thing that happened was that you had to fake time because you were too slow, and so all your timeouts would fail. And if somebody went to the disk, because you're JBoss, you write logs, you read logs, you emit Java code, you run Java C on it, all this shit happens. Java C looks 10x faster than it would in practice, right? So you go to the file system, and you get timestamps, and your timestamps do not match your current local time, which is running at 1/10 normal speed. So you had to mimic slowdown in time and the timestamps and system current time millis and every other thing on the planet to fake it good enough to run these big apps.
That's intense.
It was, but it was also, we were waiting on hardware to come back.
Sure.
And hardware guys were on their own cycle, their own universe. And we had a bunch of other fun things. Like the hardware guys would come through and, oh my God, we have to fix some random thing in the hardware. And they would change the bit layout of the instruction set and hand us eventually like an XML file with a new bit encoding. And sometimes new instructions are added or old ones were removed or whatever. And we would just run it through the compiler and out would pop the new simulator and the new everything. And we didn't care. So we would do a pull from the hardware guy's CPU description stack, and and then we'd go rerun the simulation. It was all good. So a lot of fun bugs that you can fix on either side of the hardware software line if you're willing to touch both sides and go back and forth sort of easily. So in the end, the Azul chipset was sort of like the easiest, best system to compile for that I ever dealt with. It was like amazingly good. It's like PowerPC, only nicer even to go compile for. Fine.
Can I ask what was the hash spread thing with Douglas with you?
Oh, the hash spreader? Yeah, just let me go. I just give you the code here. I just was doing something with it. Hash map long Java util hash colon this. I just totally robbed this code from Doug Lee, who at some time he told me what it was. So there's like shift zor, shift zor, shift zor. x86 will issue 2 or 3 of those every clock cycle. There's like 3 clocks there.
Because strangely, I'm on the hash functions right now, and I want a perfect hash function to map a range of integers to a fixed point, so let's say 128 slots.
Right, this is not a perfect hash.
Yeah,
right?
yeah, cool, cool.
Okay.
Yeah,
Yeah.
I have something like looks like a hash map. It finds a perfect hash for a lot of values, but not all of them, because and I'm searching for hash functions to see how they go.
Right. Yeah. I know what a perfect hash is. It's all good. There's tools that do that. I thought you could go.
Yeah, but they are not particularly good at squeezing large values into a smaller set.
Oh, you're trying to get it down to 120. How many values you packing in that 128?
Okay, I mean, maybe 2 times, like maybe
50% load factor?
yeah, but
Yeah,
almost.
okay. Huh. All right. Yeah, I don't know.
But
I've
a
never
perfect
used
hash,
those tools.
a perfect hash will always find the perfect hash for all the values you know up front. But I haven't found in Java or in Scala. That's why.
Well, there's old C tools like perfect hash
Yeah,
concept's been
mint
around.
hash. Yeah, cool. Yeah.
Yes, but I don't know the quality of the compression and right and getting one in Java or whatever. Yeah. What was asked at the end of last meeting?
The question was annotation versus
Annotation.
some keywords, modifiers versus
What's a
annotations.
modifier?
I believe he was talking about final val, final something that's counts as a modifier, I believe. Or in Rust, let mut thing that counts as a modifier.
What I'm sorry, say again.
For the Rust, you can declare a variable mutatable.
Mutable. Yeah, final.
Yeah,
right.
let mute that I believe that mute is a modifier, or at least I understand.
Yeah, right. But this is like final and mutable are all like two sides of a coin here. When you say modifier like that, I'm thinking like public, private, static.
Yeah, I believe that.
Static changes your scope. Public, private changes your visibility.
So his question is, does we do this by annotations or we introduce a keywords in the language to do it?
It depends on whether you want it to be enforced or not by the language. I mean, I think the goal of annotations is extra information that's not enforced.
It's not essential, I believe so.
Yeah, well, right. And then what's the point of it? And you get shit like not null in Java, which Kotlin then enforces, right? So you can have that one should have been in Java and enforced and is not. Fine. You get like override, which is a hint that says roll rather than shift. Yeah, you can't write roll in like C. The Java variant that might go out in Java. I do, by the way, Cameron, do the hack of recognizing roll as a bit fiddle game. So that particular pattern, I didn't look at it. It might be subject to that roll hack and might be picked up as a roll. I guess if things add 30, 20 and 12 add to 32, that would be picked up as a roll. Totally. Whereas the 13 shift will not, because that's not your even factor.
Well, but those are both SHRs, so that's not gonna get translated as a roll.
The by 20 and by 12, there's zero shift.
One has to be a SHL, one has to be an SHR to get picked up as a roll. So you'd
no, you roll by 20.
Oh, sorry, what a row means? What does a row?
You shift left or shift right.
I'm with you.
Is a roll.
I'll buy it. Yeah, I'm with you. So there's a minor modification that we could because I pick up the roll. I do pick up the roll hack. Yes, rotate bits. Yeah, totally. It just how fast can you make the spreader? It adds a clock cycle or not to your hash function.
Roll is rotate left, and roar is rotate right, and lol is laughing out loud.
Yeah.
Does the CPU laugh? Or does the CPU lol or you?
The CPU has a roll instruction. It's a old school CPU, but most of them have a roll. And only hand roll assembly guys use rolls, like compilers. I mean, I do it, but you have to have things like this where you have a bit fiddly game that you would ever end up with a roll. The issue is, of course, it's like essentially free to throw it in the hardware at this point in time. So you might as well have it.
Rotates seem to be common in hash functions and crypto algorithms.
Yeah,
An
because they
actual
don't.
rotate. We're talking about hash here. So we're looking at the hash in the chat. It's not a hash.
No, when I said hash, I mean like cryptographic
crypto
hash.
hash. Oh, yeah, they could be
They're
used.
essential. Yeah, they are essential for that.
Yeah, okay, fair enough. Yeah.
Yeah, but back in the 1970s, the transistors were expensive enough that a lot of CPUs didn't have roll instructions, and you had to emulate them with shift instructions.
Right. Well,
But they
actually
also
picked up a roll early on, though.
because I can remember, for example, we used to have we used to have to count the like 0 bits and 1 bits and stuff like that. And then Intel added those instructions in the mid 90s. They added XCHG, which was the endian flipping.
Right.
That was handy because we used to have to do that by hand.
Yeah, I never played a network stack forever and a day, so I didn't do Indian flipping very much.
Well, it was important with Java because Java always provided a view of its integers that they were big endian, and of course, no one actually used big endian hardware.
That was
I'm joking, but
I just bypassed fine.
Yeah, but I mean, all the x86 stuff was little endian, so you knew under the hood it was all in backwards order.
Yeah.
But anytime you looked at it, it had to show it in big endian.
I did the JET. I don't think I ever had to do an Indian flip in the JET. You had to do a network.
Right, but you have like integer. You have
serialized
integer. There's some way you could, like
I think it's data output stream or whatever has a put int that writes 4 bytes.
Yes.
In big endian order.
Yes, as soon as you went to a network buffer, you saw that, and yes. Those guys played the game, and I was just like, fine, whatever, guys. But I got why. They were trying to be serializable, and so they wanted to flip between Spark and x86 in serialized format. You had to agree. So your son, you agree on Spark.
Well, son was more interested in Spark at the time Java was invented, so you can understand that.
Well, that was where they got their money from, yeah.
Yeah.
Yeah, I was a Sun employee back then. Java was selling the hardware, but the hardware paid the bills. Let me pull another guy here.
Yeah, I like the Spark hardware. One of the probably my favorite sort of architectural feature is the register windows. I thought that was a really neat idea.
Oh.
Not necessarily spilling to memory ever, right?
Right. I did the port to Spark, to Itanium, to Azul. All these had register windows. All 3 register windows behave differently. And of course, you did on x86, which had no windows, and PowerPC, which had a lot of registers and no windows. And getting all of those to work well was amazingly difficult. You want to do a stack crawl, so a lot of places do stack crawl. Well, half your stack is stored in the hardware registers, and so you had to flush them to memory to get at them. While they were down in memory, you fiddled with them because you're the garbage collector and you're changing pointers. The hardware, meanwhile, has taken interrupts and reloaded those values, but they got half stale and half not stale, but they're just pending in its back of its mind. So when you got done filling the stack, you had to flush the register windows without writing their contents back. And then you could tell the hardware to take off and start reloading the stack again. And getting all that right, realizing you had to get it right at first. And we had a lot of bugs that were very low frequency, where it only happened if you took an interrupt at the wrong time, that prefetched the register windows that were in the middle of the garbage collection cycle, editing the bits. It took forever to track out that was the bug, and then to put in all the final places where you had to force the stacks to flush properly, left and right, up and down. And Itanium and Azul actually had variable length register windows. So they had another different hack you had to deal with to go force the stack to flush out or not. So there was stack crawling code, and all these guys are, it was excitingly different. Fine. Water on the bridge. Yeah, you know, could have been a cool idea. Actually, even on today's hardware, it's probably, today's silicon styles is probably still a good plan. Intel's, you know, water on the bridge can't go there, but if their ARM had a choice in life, you could debate register windows again. Intel just throws a shit ton of hardware at it. Okay, what else? Annotations. I can rant on annotations, but only a little bit, but I don't care.
What was the, you were saying something about last week, I got thrown under the bus. What was the,
Oh,
topic?
that was to do with, that wasn't thrown under the bus. It was, you have a functioning setup for doing inter-process communication where, you know, there's some attention paid to efficiency, so you can pass a pointer to a message across a service boundary and shit like that. There's some thought about efficiency going on here, and it's like we looked at Erlang and talked about it briefly, and then pointed out that, you know, it's great to do message passing as a way to not be able to write data races. So how do you not write data races? So message passing is a way to not write data races. As soon as you do that, everybody who's done that in the past has also had to have a shared common core data structure. In case of Erlang, it's their database that supports concurrent independent updates with good atomicity properties, but there was some way to do a generic system-wide broadcast of parallel data, not just point-to-point passing a message. And I was, you know, didn't know, and we kind of, that was kind of where that one ended out. And then, like, you weren't there. Now I ask you the question, you know, what, if anything, have you thought about for doing anybody who wants to do, like, you know, we actually talked about this, like a JDBC driver. You're just going to make everyone pile into the JDBC driver server, which under the hood has a border that you can make anything you like, right? Like I have a 72 core machine. We're all wailing away on web services. We have caches of web URLs, we have caches of JDBC shit. We have a bunch of big parallel concurrent caches. We want to have a bunch of big parallel concurrent caches. How are those implemented in Ecstasy?
Right. And I think, you know, so first of all, kind of step way back, you know, we have a lot of 80-20 rules in software, right?
Yeah.
I mean, 99-1, whatever. But where we kind of divide a problem into smaller and smaller domains as we kind of shave the yak or whatever you want to call it. But, you know, there is I think it's worth saying that there is a class of problems that requires shared, mutable, highly concurrent data structures.
Okay.
And that class of problems, I think, gets smaller and smaller over time, but it is still a pretty fundamental class of problems. And it's one that we are explicitly not trying to solve. Like Java solves it well. C# is learning to solve it well. C++ cannot solve it well. No, it can't. I mean, it's provable that it cannot.
Wait, why? I thought they got their memory model sorted out. That was sort of the last big hurdle.
Because you cannot, you fundamentally cannot solve that problem without garbage collection.
It is a lot.
There's a proof for this, and I can't remember who wrote it. But if you do not have garbage collection, you cannot solve the fundamental problem. Anyway.
Right, but then you get into like, what is your definition of garbage collection? If I use a bunch of C++ unique pointers or arc pointers, like
you can solve, again, it's shaving the yak, right? You can solve parts of it with smart pointers, for example, right? But we're probably borderline religious discussion at this point. Like C++ is good for very many things. It's not good for this area, and it is where Java's wiped the floor. You know,
having done this, I will claim it was very hard. Hotspot's full of internally shared mutable data structures written in C++. and data leaks were an issue. So I won't say it cannot be done, at least in the running of a JVM. Cat, why are you hanging out the door scratching?
Well, I think it's safe to say that you can solve any particular problem with any particular language.
You beat yourself on the head hard
The question
enough,
is does the design of the language solve it for you, or do you solve it despite the language? And there is a fundamental difference between those two things.
Yeah, totally. We
Or
solve
make it easier. Or make
Yeah,
it
so
faster.
I can solve anything in C++.
Yeah, fine. Your turn.
But I will often hate my life while I do it.
Exactly.
So,
Fine.
That is much more fair.
yeah.
All right.
So anyway, you know, so think about it this way: with simple concurrency, with mutual exclusion concurrency. So say Java 1.0 synchronization, for example. The idea is that you've broken down the entire domain of your information model into rooms, and you can go into any room, shut and lock the door while you're in there, and no one else can come in with you, right? So you get to muck with whatever you want, and then you get to leave. So that was your synchronization model. With the CAS model, you have the ability to swap the entire room out based on a previous state of the room, right?
Mhm.
And so those are kind of the two fundamental concepts for concurrency. And we do actually have the CAS model, but we model it as a lightweight Erlang process, if you will, what we call a service. So if I have, for example, an atomic int, that int is itself treated as a service. In other words, it looks to the developer as if it is the endpoint for a message.
So you are sending a message to an integer saying, please be 3 higher.
So of course we are not sending a message to an integer.
Yeah,
But we pretend very hard that we're sending a message to an
Does
integer.
the integer have a mailbox, or it increments right away? With the actor model, you have like a mailbox, and instead you synchronize it. You have a +3 on the next +4, +5.
So the idea
messages.
The idea is fairly simple, which is you want to have everything follow contracts, right? Everything must follow a contract.
What's a contract?
So the whole actor model, for example, is based on, let's simplify the set of contracts, and then we can describe everything in a predictable manner based on those contracts. Contracts have two sides, though. And when you're designing this, you have to think of those two sides like simultaneously, right? So the one side says, this is what I do for you. These are the guarantees I provide. And developers love those guarantees, right? The other side of the contract is, this is how I screw your architecture by existing, right? So every contract you have is a grenade, somewhere between a grenade and an atom bomb, right? So you have to figure out which contracts am I happy to have in my house and which ones am I not happy to have in my house, right? So, I've used the example before of the, Java has this identity on every object. So you can ask the identity hash code from an object, right? That's a contract, right? And at the time that they wrote Java, it was free because the garbage collector didn't move data, right? So it was a collection. And they're like, oh, this is free. And because it's free now, it's free forever, right? And it turned out that was an atom bomb, right? Like
not free forever.
It turned out to not be free forever. So, what I'd like to say is, like, services for us are like rooms that get to move around, right? Like it's a room full of data, but only one person can be in that room mucking with the data at a time, right? But
this is like a mutual exclusion. He and no one else.
Right. But it's mutual exclusion kind of at a much higher level than, say, an object, right? Because with synchronization,
at the concept, at the service level.
right? With synchronization, I have so For example, in Java, you can write a very simple test that has two objects and a bunch of threads, and one thread will synchronize A then B, the other synchronizes B then A, and you get deadlock in a hurry, right? The idea with message passing is that you can't get deadlock at the execution level. You can get deadlock at the logical level. You can create a situation in which you achieve deadlock, in theory. But at the execution level itself, it's impossible. So then the question is, once you have that fairly expensive contract, is it designed in a way that it can disappear? And that's kind of what the goal of our model is that for a lot of these contracts, even though the contract still holds, we want to be able to get rid of all the overhead of it. So and services and containers basically a type system with multiple services within it, but it is itself a service. But those are basically the two biggest things we have to finish designing out that overhead.
So you plan to get rid of the overhead and you haven't got rid of it yet.
Well, right. So right now we only have the proof of concept implementation. So we have designs to get rid of it. We just don't have it.
So I want to address briefly the notion of queues for your services here, or your actors. I claim the queuing mechanism is not part of the design of any reasonable actor message passing. Instead, it's part of the implementation effects that you do for efficient, scalable, blah, blah, blah.
That's correct.
Whereas if you're doing a service of an atomic update on an integer, cas if equal x go y, you don't need a queue.
Correct.
You can ask the question and spin, and your queue is effectively every CPU has exactly one pending outstanding request they're attempting to get done.
So we pretend that there's a queue.
Yeah.
But it doesn't actually exist because you get your answer back before you even put something in the queue.
Exactly.
Yeah, exactly.
There's no need to efficiently implement a queue there, but effectively there's a queue of all pending concurrent CPUs that are fighting for the same word.
Yeah. So it's a high concurrency queue that happens to have zero latency.
Yes. No, the latency is bound by the set of CPUs that are trying to get at it. If
the queue is comprised of what is in the queue? The queue.
There's nothing in the queue. There is no queue for an atomic.
There's no for an atomic update. There is no queue, except that every core in the hardware only, every core that's beating on that one address and attempting to cas is queued in the hardware, one per CPU. So you're maxed out of the count of your CPUs. Furthermore, if you have if you're doing your spin because you're spinning to do an increment,
right?
Then you're in the spin somewhere, and that is part of the queue for that one core. Right. So for instance, if I went to Hotspot and said, hey, take all your performance counters and make them atomic updates, then the system would suck for performance, because on a 70-core machine, every core wailing away, they would fight for these performance counters and do cache line ping-ponging of a horrific 70-way cache line ping-pong, and you get this enormous slowdown.
You fix that by striping the performance counters and having them all on different cache lines?
No, you fix that by doing non-atomic updates. And you deal with the consequence of non-atomic updates. I've talked about this before, this thing. If you do non-atomic updates, you drop counts. How many counts? What percentage of?
And if you're undercounting meh.
Yeah. Like two guys are in a loop, and the interpreter wants to know should it jet, and they're bumping a counter. Okay, so they're fighting, so they drop some counts, but the count hits 10,000, and you fire off the jet. Okay, the loop's big, and much of it's jetted already, and you're doing really fast through it, and you're still doing some counts. And 70 cores are wailing away as fast as they can, and they're beating on the counter, or all the counters. Some counts get dropped. What percentage of counts get dropped? This is a magic trick question. So
I would think with two, the worst you're going to run into is that half of them are getting dropped, because everything that you do is overwriting the other core's action. So you only get half. But my guess is in practice, you're going to get closer to 70-ish.
You're heading the right direction. 99.9% or worse, because everything that this core who wins the update puts in drops everything that all other cores missed during the entire cache line miss cycle time that they updated, that they read in their cache, but they couldn't get a thing to go back until they got ownership of the cache line. So all the updates they did during a cache line ping pong time are all dropped. So you get one update per cache line ping pong, and everyone else drops all their counts all the time. So you get an enormous drop rate. So buried in the hotspot jet is this heuristic which says if all counters have saturated, it turns out when they all drop uniformly at the 99% level, and all counts look the same. So if I have a loop that's got a diamond that's got a 90%, 10% split, and I'd love to JIT code differently for the 90-10 split. So I have counters on each branch I'm trying to count. If the counts are low, if the thread count's low, I keep my counts, I have a 90-10 split, it's very obvious. If I run a long time with high count threads, these two numbers saturate to an even value. Because it's cache line miss per update and not how often you touch it per update. So at 70 guys in there, always both of them getting touched every cache line miss, and all other counts are dropped. So I get one per cache line for both of them every cycle, every cache line cycle. So that all their counts saturate to the same value. So I lose the ratios to percentage differences, and there's a heuristic in C2 which says this appears to be a pile of saturated counters. I'm assuming that there are variations that are interesting, but I don't have that data. I have lost it in the saturation. So I'm going to flip back away from the performance counters heuristics to the old school C counter heuristics, which say, I guess this branch is a 90-10 split based on its appearance of a null check, which typically split 90-10 one way or the other. Shit like that goes on. There's a lot of those old school C heuristics, which make sense back in the day. When you have performance counters, you'd rather have performance counters. I have a point there that says, and all your performance counters are dorked, give it up. Go back to the old heuristics. That was some of the fun learning about performance counters. And you can never make them atomic because that's just too expensive, even if you were to stripe them, because the atomic requires you, back in the day, it required you to wait to main memory, 300 clock cycles, and blocked all other memory ops because it was x86 atomic counter. Atomic updates are a fencing point. So you would wait 300 clocks on your 700 megahertz machine to delay every memory op. Just cannot do it. And Azul in particular, the CAS hardware had optionally fencing. And so you would say no fencing because it was a performance counter update and I wanted it atomic, but I did not want to stall on memory. So there was no ordering guarantee.
And that's better than having one set of counters per CPU?
Yeah, well, you can't, yes, because the counters are spread all over the map. So the counters go to the code, not to the CPU. So I'd have to have all counters for all code striped by CPU, which I'd actually don't, the OS flips the CPU and doesn't tell me. Like I need a different OS that flips the CPU that when I get restarted after a stop on a CPU, I get told what CPU I'm on. So we did do, like we wanted profiling, we wanted, priorities, which we didn't get out of the OSs at the time. So we did priorities with locks and blocks, and you did shit like ask questions, what CPU am I on, periodically, and you were mostly on that CPU, and occasionally you got knocked off and you were on a different CPU and you choose a different thing. I said priorities, we did that too, but I think I'm confusing it. What I was trying to say was we did things where we had CPU local data on a machine that didn't have any CPU local data, which we faked by saying, what CPU do I think I'm on? And that only is good for a little while, and then you got knocked off. So you had to keep re-asking the question. So it was just a design, I don't know what you call it here, a hardware, software design game. The language gave you no support. The runtime basically gave you no support. You faked it all the way. But you could do it if you had a repeat loop where you were touching data periodically that when you tended to want it to be striped CPU local, you could ask the question, whatever.
So would you like a hardware to be able to give you something like allocate me a small block of memory that is in the L1 cache of this CPU and no other CPUs touch, and if I use the same pointer on the other CPU, it goes to a different place?
Yeah, I've totally used such hardware. And that's you just have a private. You have a private.
Yeah, thread local is handy, and so is CPU local.
It's CPU local. It's not even thread local. It's very different.
Right. No, that's what I meant.
Okay. So this was CPU local, and so you had to have the OS tell you not to flip CPUs, or you lost your CPU local memory. Many small embedded systems fall under this camp. Okay, I have admitted trolls twice. Let's see if he makes it this go around. He is failing. He's gonna make it. Oh!
Yes, did it this time. Great.
Yes. Okay,
I have an issue where my Zoom is quite unstable while I'm joining a meeting. It's perfectly stable once I'm in, but it's kind of a gamble.
Yeah, I have to keep hitting the admit button. I get like 3 waiting to join things. 1, 2. I have to keep clicking admit, 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 and then they all time out, and then eventually. There you go. I don't know. We were talking atomic performance counters and services for atomic updates, and
let's switch now. The themes: inheritance versus composition.
Oh, I wonder how many people got the time zone wrong. Hang on, let me grab your. So the meeting's been going for an hour. It's now 11 o'clock my time, not 10 o'clock. For people in Europe.
because daylight savings.
Yeah, so I said PDT and not PST on my Twitter message. And the secret, code that you missed was the S versus the T.
Yeah, there are 3 problems in computer science that we haven't solved yet. Date times and off by 1.
Yes, exactly.
But it does show a lot of faith in you that people are like, well, he said PDT and not PST. I don't care what time of year it is. I'm sure he was being precise.
Yeah, truth be told, I don't really read the tweets. I just have it in my calendar.
I know. Yeah, I know. And I don't change the password or the link on purpose because it makes it easier for everybody. And the porn bots haven't found us again, so it's all good.
Yeah.
They
If everybody
are
changed,
going away. The time changes are going away in Europe.
Says
yeah,
who?
so either the time changes go away or we all change at the same time, but changing at different weekends doesn't.
Oh, yeah. Talk to somebody like I'm working at this company that's distributed remote. Half their people are overseas or East Coast or West Coast, and everybody's time zone flips at a different point. We were all like dorking around laughing at it.
So what was the question on what was the question on inheritance and composition?
What do you prefer, inheritance or composition, and why?
Define composition though, because it's kind of an open-ended.
Inheritance like extends interface classes. Composition, you bring some struct in your code, but not through inheritance. You require it as a parameter from.
Yeah, I certainly like the way Go does it better than the way Java, for example, does it. Where it goes like, just stick the other type inside your struct, and I will essentially using the namespace so you can use all of the same names. But
does the implementation do object inlining? The other thing that you get out of Java style and C++ is that you get object inlining for these subclasses, which leads to its efficiency. It's a decent efficiency. And now the question is Go do that as well, which they could.
I would guess yes, because their composition is part of their like struct initialization and struct sizing stuff. So my guess is it's just like, hey, I'm building a new struct. Go look at this other struct for the first set of fields.
And align them carefully so that you can, you don't, you're doing composition. It's like inheritance. I got to hand you the prefix struct, the extended struct, and identically it matches the prefix, which is the whole point. Mm-hmm. Is that possible in Go as well, or I don't know enough about those inheritance.
Yeah, I think it'll just blow up at you if you give it a composed struct.
Yeah.
In the place where it was expecting the parent struct, it'll just be like, this is the wrong type. Please say type dot parent struct name, and I'll give you just those fields.
Yeah, I mean, Go has all of the object orientation of the original K&RC.
Well, that's what I was wondering. That doesn't. And that's not inheritance. So that you miss the goodness of it then, right? The goodness is I can hand my animal, which has subclass of cat, dog, and whatever, off to a thing which only does animals and doesn't know cat or dog. And never mind the virtual call, you can do an animal thing. How many legs does it
So
have?
I believe the
Have them
Go you
go.
can. I believe the Go you can pass. They don't have interfaces or something like that. As long as you implement the methods for, let's say, for an animal, you can pass it.
So that's duck typing.
Yeah.
No, it's well, structural typing. It's not statically checked.
It's not statically checked.
It is statically checked. So it's not, I mean, duck typing is, well, it depends. Duck typing isn't formally specified, but
I'm thinking of
it's-
duck typing with static checking, not dynamic.
yeah, okay, that's what it is. That's structural subtyping, I think they would call it. But yeah, that's what it has.
Structural, yeah.
Oh, it's structural subtyping. Okay.
But it likes functions, not fields. If you're like, here is my duck, duck dot name, and it's like, that's not a thing. And you're like, duck dot get name. And it's like, oh yeah, that's fine. You can totally. The interfaces are all over functions, not fields.
Gotcha.
As far as I can tell. Maybe that's changed.
And the embedded object that you're nesting inside is actually its own separate thing with a pointer to it, or the fields are inline? That's the object inlining question again. You don't know. Okay.
I would certainly hope they are inlined. Otherwise, I would think it would be slow.
Yeah, it could be.
Garbage collector has to deal with interior pointers. So I guess you can have a pointer into like some little struct inside of a bigger struct that has a bunch of structs. And
well, if you do the
collector's aware of that.
If you do the prefix only version of things, which is the standard subtyping game, the garbage collector just needs the base and it's done in the class. But if you do true interior pointers, then you kind of, I won't say you hobble the garbage collector, but you definitely add a lot of complexity. Same as like putting the hash code in Java, the fail that everyone has a hash code in Java. It adds a whole lot of issues to the GC. Because if I hand off this interior pointer to somebody else, it's not a base pointer, it's an interior pointer. So I have to make it fat, so I know where the base is.
Right.
I'll have to be able to go from the base of the interior object to the true base.
Right.
So there's some extra data stored in every object everywhere that says from the pointer, I can go backwards to the base or whatever, and that inflates all objects, which blows out cache and memory and bandwidth and shit like that.
Where you play Microsoft's game where there's, I don't know, I think they call it a thunk, right? So they deal with multiple inheritance differently than, say, GCC would do. And
I wasn't talking multiple inheritance. That's its own set of ugly.
Yeah, it's a different set of ugly, but the interface type that you think you have may not be the beginning of the object that you're given.
Okay.
And so the virtual function pointer that you use points to some place that knows how to adjust this pointer properly for the thing that you have.
You have a different function pointer for each.
Based on the call that was made.
Yeah. Based on each object type that's coming at a virtual call, where the function pointer carries the offset to the base.
Yeah. Well, it's not the function pointer doesn't have it. The function pointer points to, an extra couple of instructions that adds or subtracts from this.
That's what I meant by the function pointer has it. Either, I'm not claiming the function pointer bits themselves. I'm saying it points to either code, or you have a hash lookup based on the address of the function pointer, any number of variety of ways to do this. There's a lot of ways to skin the cat. But the key data is carried in the function pointer as a way to distinguish that this is an embedded object that came from the following base.
Right.
It knows how to get the offset. Yes.
You have to be doing something like that, because I've seen things where you like load a giant JSON object and then save one string from it, and you end up with a long thing.
No, that's a string. That's a string substring operation.
Because you've got some slice, and that some slice is over the entire string.
Are substrings a slice, or are they a copy of the original?
Slices for the most part.
And people have gone back and forth. Java's gone back and forth. Because suppose I hand you a gigabyte of XML and you hunt through it and you find the magic bit you want and you say substring. Well, if I do a slicing, I hang on to the gigabyte of XML forever. Right?
Let the garbage collector save you and be like, hey, you're the only pointer into this gigabyte of XML. I am going to make a copy of the 1K you care about, and then
the garbage collector doesn't know objects have semantics that say they only care about this. What the garbage collector sees is I have an object that has a pointer to the base and a freaking offset with just an int, right? Now go prove to me that all values are not, here is this guy.
Yeah,
All
I think
access is from here.
Yeah.
Don't touch anything outside.
For that, you would need a mixture of garbage collection, well, tracing collection, and reference counting, because otherwise, the tracer wouldn't be able to determine, hey, you know, there's only this one slice to this this entire big array.
Questions about one pointers can be done in GCs, not by n though. It's not too hard to track that exactly and only one guy does point to this dude. But as soon as you have two or more, you can't count, you give it up and you say, yeah. You know, it's zero and zero versus many, but you can go to 0, 1 many without too much more grief. But you can't go beyond that. Or at least I haven't seen somebody try it or do it. There were things with one that was useful, like reorganizing the layout of memory such that all pointers to pointers to pointers all landed in the same set of cache lines, so you could prefetch by walking a linked list by prefetching. The hardware would prefetch for you. If you force a linked list, you know, Cameron's busy taking his linked list and inserting and deleting in the middle of it and screwing around with it. The GC comes along and realizes there's all one pointers to the next guy, then he wants to lay them out. So they're all one pointers to the next guy. And then the hardware, when you walk the linked list, well, prefetch. I don't know. Things went around there. But yeah, as soon as you have two, you can't do it. And the real question is you have to look at the semantics of string behavior to recognize you want a substring, which the GC is not into code analysis, so it doesn't do it. So that gets into, I want substring to copy. And sometimes you do and sometimes you don't. Depends on the use case. I think Java went back to the copy, had been doing it as a offset, and then went back to copy because it was easier for the performance model. Everyone understood it.
Yeah, the downside was known.
Yeah. And if you want to have the pointer into the middle, you roll your own, which I do periodically.
Yeah, I spent some time, probably, I don't know, a decade ago now, back when Java was still had was doing the substring, was using the old one. And I specialized the handling of string objects because we already knew about them for other things in the GC. So I was able to recognize, like you said, Cliff, you only need to know if there's exactly one or more. And if there was exactly only one and your length was way shorter than the char array,
you did it.
I could set it up to redo something for you, but it gets really hacky and dirty. It's not good.
So in Azul, we were looking at forcing string and car arrays to have a butted headers, and we wanted one only, so we would know that there were no one who was pointing badly. And then we would start from string, and we wouldn't do the load. We just add the offset of the string length and get into the car array as a shortcut for common case of a tiny wrapper around an array.
Yeah, we did the same thing for the metronome, the real-time collector. I was embedding the char array inside the string because we use cell-based allocations. I'm like, in a bunch of places, you knew exactly that you were going to be allocating these back to back, and I'd put them in the one cell, and it was easy.
Yeah, okay. But you didn't have to deal with the generic string header and string car array were disjoint. Like you don't. So if you never have, like, what does the JIT do? If you never have them split, the JIT can always write the code that assumes they're together and just object inlines them, away you go. As soon as you have some split and some not, the JIT has to ask the question, are they split? And that's already the cost of doing the load to go to the second array and not care. So it seems to me the benefit is everybody has them adjacent, but that puts a rule on how you make strings that when the car array gets made first and screwed around a while, and then the string gets made, you have to like wedge them right away into the correct format. Is that, would you guys answer that question?
That's how I was trying to do it. It's like if you made, and it got really hacky, and the JIT guys didn't like me at all. So we ended up we didn't go forward with anything. It was all prototypes, and they're like, get out of here. You're basically making our life hell. And I was like, okay, I was trying to make the GC look a little bit better and waste less memory, but at the overall cost and complexity for the compiler, it just wasn't worth it.
Wasn't working. Fine.
No.
It's good to know that you tried, though. We looked at this hard at Azul, and we went back and forth and decided, couldn't do it in the land of Java, but a minor language change would let you do it. And there was big benefits for, a big business data logic, tons of strings floating around, be very nice.
What is the language change that you think makes slices more reasonable?
I'm trying to remember now. No, you couldn't have another pointer to the car array which strings already in defensive copy. You had to know that all strings and all car arrays were made at the same time. Not all car arrays, but all string headers were made with a car array at the same time, so that you could force them to be abutted. Oh, and there was an interior pointer problem. You couldn't let the car array escape either. Strings these days might be able to do it.
No, they don't want the char array to escape because it's considered immutable.
Yeah, it's a total security hole. Yeah, because it's immutable.
But there are some open source packages that abuse that, so it would break if they changed it.
Oh, really? They doing things with reflection or something?
Yeah, using reflection to get to the what is it called, value or contents?
Yeah, your reflection value. As soon as you do that, you're dead. Which I guess I'd be willing to claim you're dead. I mean, we had people who were changing final fields via reflection.
Right.
And I tried the compiler optimization of final fields and broke. And it was extremely difficult to debug and finally find that somewhere in the middle of the Spring framework and two other large common frameworks, they were hacking final field zero reflection. And then I went and complained to one of them and they said, yeah, it's bad. We know it. Oh, okay, we'll change it. But you got to make everyone change or you don't run. And, fine. What a pain in the neck. So this gets the same problem with the string guy. You'd like to go ahead and say, and the language spec is thou shalt not. And if you do, it's like using unsafe. You just blow your brains out and you're dead. Fine. You're allowed to commit suicide. Because that's the common thing with strings. It saves that indirection every time. So technically speaking, third-party string libraries, well, no, the problem is that the JIT has to kick in to do the right behavior, and they have to be usable by everybody else as a string. So sort of the horse left the barn, the strings you can't go back on unless you're willing to break a handful of bad behaving people, which maybe, sometime you are. Every large Java app runs 10% faster at the expense of a bunch of bad boys, a handful of bad boys getting broken.
I heard that some engineers in Databricks, they have like huge framework to deal with strings.
Yeah.
And to solve this problem, they have like ad hoc version of string implementation. They use their own version of string library to solve this problem. Yeah. So if this kind of problem can be solved in third-party library, then we don't need to drag those kind of technical complexity into JIT or garbage collection, because this is like ad hoc problem.
Yeah, we missed the connection here. The benefit is the JIT emits special code for all strings and all users. If I write a hand-rolled string library where my strings have the right behavior, that I get a compressed, combined car array and string header kind of thing out of it, which I don't know how to do in Java. You can't do that technically in Java. Then but if I did one, then it only works with my strings. So my own system does it, but I can't use any third-party libraries. I can't do whatever. And I do hand-rolled string things in several domains. I do big data string parsing games. I don't want to make a capital S string because memory bandwidth sucks. So I make a string-like thing that backs over a network buffer that's constantly shifting on me. And that's a hand-rolled string library that has better performance characteristics, but it doesn't go for everybody else.
Well, this is a standard trade-off when the fix can be very simple on the application level, or you can do heroic efforts in order to make the same optimization of the compiler.
Well, I was looking for a minor language change that then would not require a heroic effort on the compiler, and everyone would benefit right away. Or I'm lamenting the lack of it. How about that? you could claim history and no one knew, and so we're stuck, and that's a reasonable state of affairs to be stuck. But sure would have been nice if, back in the day, Java done strings a little differently, Java done hash code a little differently, Java done finalizes a little differently. So maybe I'm whining about past history and I should quit. Fine.
Right, but I think it makes sense that like, if those people could have gone to a club that focused on love of compilers and coffee and learned how to not hit this mistake when they were designing a new language, that would have been great.
Right. Some of those things I knew were a mistake back in the day when I saw them and I didn't care. And some of them I didn't. I didn't have the string thing figured out back in the day. And, Java was doing what Java was going to do. I knew the object headers having to hold hash code and locking and GC bits and class identity was a mistake. That was too much. And there,
you knew class identity was a mistake all the way at the beginning.
Class identity, I didn't.
I assumed we didn't learn that was a problem until much later.
Yeah, I think class identity is not yet a mistake. I think there's reasonable subclassing that's okay. And certainly at Azul, we compressed the class identity down to a smaller count of bits, and then there were lots of room in the header for other things. But I would never throw hash code or locking in the header. I would claim hash code and locking are rare enough that you just put them off to the side and you claim I'm hashable and I have a hash field and I compute a hash, or I'm lockable and I have a lock, or I am a lock, or whatever, however you do the locks, but they're not every object can be locked. That's not a good plan. Finalizer is another different bad plan. I don't know how many other bad plans in Java that were really bad even back in the day.
Well, there's an argument that the covariance was a bad one, but happens to be one of my favorite features of Java, so I'm not gonna argue.
Yeah, I claim that's an open question still. I've seen it other ways, and maybe it's not so bad left and right. The memory model I claim was never in the original JMM, but they changed it and got a correct memory model, and that makes a big difference. That lets you do concurrent.
I don't think we finished Cameron's question. What's your objection to covariance in Java? Because it isn't really part of the inheritance picture, but there are bridge methods generated to allow somebody that knows more to get more. But if you don't know more, you don't get more.
Well, I like covariance, so I'm definitely not.
Oh, I thought you were saying it was a mistake in Java.
No, I like scalar covariance.
There are people. So Brian Getz, for example, is a huge critic of the covariance in Java.
Oh, really?
Yeah. He considers the array covariance to be a fundamental bug.
Arrays are different story.
Yeah, arrays. I don't know. Hey, nice seeing Charlie. Yeah.
It does seem like there's value in really baking arrays deeply into your language and being like, okay, if I need 128 things and thing has a size, it should have one object header at the front that says, I'm an array of 128 things.
Oh yeah, that's another.
Whereas Java really likes to do the like, I'm an array. Each one of these is another pointer that goes off. Please spend your entire life pointer chasing.
So Java did right. You can have array of primitives. So I think primitive arrays, those are perfect. Now, what you said was
Java did wrong by having primitives, but okay.
But I want is a array of anything fixed size.
Yeah, so now can you have an array of anything fixed size where you inline object and get rid of headers? It only counts, it's only interesting for small objects, but there are plenty of them floating around, points or complex things or whatever, where the point is an X, Y, Z, or an RGB.
It also goes back to the mutable versus immutable and the 0, 1, n questions. So if the objects are immutable, then it's a lot easier to inline the structures in the array. And if there's 0 or 1 references, then it's also a lot easier to put them in the array. When you have n references to a mutable object, loading the object headers, if you will, what Cliff says headers, the structures of the objects themselves, if you load it into the array contiguous space, then you have trouble.
Interior pointers, like if I disallow interior pointers. So you can't point to the middle array. The JIT does its own thing under the hood. You don't get the JIT be efficient. Never mind the JIT. So no interior pointers in the language. So if I have an object embedded in an array, I have to reference it by the array base and the index every time. And the JIT cleans up and optimizes and blah, 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 but you can't take that address of that object and pass it off. Is that a reasonable language choice? It lets me inline RGB, which is 3 bytes, as a fixed size struct for an array of a picture, right?
Yeah, but RGB is easy because it's immutable.
No, I'm totally mutating the picture.
Yes, but the RGB value itself is immutable.
Why?
The same reason an int is immutable.
Oh, I see what you mean in that sense. No, I'm trying. I can side effect into the array. So I have a point which contains interior 3 bytes RGB, and I'm totally changing the point contents out by mutating the array directly, or not. And this is the language question to go back and forth on. Just like an array of primitives, I got a bunch of ints. I throw the higher bit away. I have 3 low bytes that I'm using for my RGB. It was wasteful by a byte, and I had to have a bunch of wrappers to go deal with talking about RGB. What is the language to help me here? But I don't ever talk about an interior int. If I copy the int out, I copied by value the whole damn int. And you're right, in that sense, it's immutable.
Right. So if you had let's say I had a mutable, pick something larger. So we'll go back to your cat, dog, animal example, even though I hate that. So I have an array of animals, right? And let's say that I know that I'm compiling the code. I see there's 2 kinds of animals, cats and dogs. One is, 24 bytes and the other is 30 bytes, right? So I'm like, okay, make it 32 bytes and we're happy. So I create my array and I have 32 bytes per element, right? And I have a discriminated union of, no value, cat value, dog value, right?
Right.
So when I knew a cat and put it in the array, I can inline that as a, fill out the structure inside the array. Everyone's happy. I hand out a reference to that cat somewhere else. Everyone's happy.
No, I'm claiming no, you don't.
Well, wait,
Yeah.
You said the JIT was
suggesting that reference is a fat pointer that both says, here is my pointer to the beginning of the array, and here is the index into the array. When
That's
you say
what I'm talking about.
Pointer? Like,
Yes.
what does pointer mean?
As soon as you have your pointer, shit get ugly.
It has to have a little bit extra data, because what happens is then someone else comes along and says, array the same element, replace it with this dog, right? So you have potentially 50 things still pointing at the cat, which only exists in the array. So at this point, the cat has to be lifted. Yeah. You have to repair all of the pointers into the array.
No. Don't go there. You start by disallowing that one at the language spectrum.
But that's why immutability is your friend. Right?
No, that's different. That says I'll allow this interior pointer if I'm immutable, but if I'm mutable array, no, can't do it.
Well, the lifting is easier with immutability.
You don't necessarily, at least for the sort of covariance aspect of this, you don't necessarily need immutability.
It's not covariant. It has nothing to do with covariance. Covariance is its own exciting question.
Right, but that's what I mean. Like if you want to have this case of I have a list of animals as an argument, and I give it a list of cats, and I don't want to be able to push a dog in it. You don't necessarily need immutability for that.
Need covariance.
True.
Yeah, you basically need to be able to distinguish between, I am the single owner of this thing versus it's a reference. And then you can say, hey.
What is the alternative to covariance? Hanging immutability and interior pointers aside, what's the alternative covariance on arrays?
So the example actually that I am looking into for my language, where I am sort of moving towards this ownership model, the thought process currently is that when you take when you have, say, a function that takes an array of animals, for example.
Yeah.
If that function if the argument is owned, you can push cats, dogs, whatever in it, because you take ownership, and within that function, the type is, array of animal, not a specific one. And I'm considering that if it's a reference to an array of animals, the input also has to be typed as an array of animals. Like you can't give it an array of cats. And there are some, like in theory, that would be doable. because it means the sort of initial owned values has to be typed as an animal.
You would claim that if I don't get ownership, I'm only allowed to know the named function type or the named array type I'm passed in, as opposed to the actual sharper type.
Yeah, the thought process basically, and there's a couple of downsides, and I have to sort of work out if this would actually work in practice. But the idea is that, you know, when you have a reference to some sort of collection, the subtypes have to match, like they have to be identical. I forgot which one of the variants that is. In other words, a reference of an array, so a reference to an array of cats is not compatible with a reference to an array of animals.
Yeah.
It has to be a reference of an array of animals as the input. And the other way around also, of course.
If I load from an animal, well, no, what's the issue? If I have two references, one to an array of cat, one array of animal, what's the conflict here?
Well, so if the argument would be an array of animals, you could push
I'm sorry. If the argument's array of animals and you pass an array of cat, no, that's toast, because you would store a dog into the array of cat and your life is bad.
Yeah.
Okay.
And I was considering extending that further. That
well, that's the Java array store check, and that's a runtime test.
Yeah, but in this case, it would be a compile time thing only.
You claim it's compile time, and you can loosen the rules if you have ownership.
Well, so the whole idea I had is basically you have an ownership model. You can only create references from owned values, and then the trick will be you cannot cast references. So you cannot say, I have an array of cats. I get a reference. I cast that to an array of animals. I then pass it to this function, and hey, I still get a dog in it.
Because I have an array of cats, and the function takes an array of animal.
Yeah, and so because references can only be created from owned values and cannot be casted, that forces the sort of owned value to already be an array of animals.
There's a read-write privilege thing there. You're okay to read from that array of the cat as an animal, but you're not okay.
But if you pass the narrow type, let's say if you pass a cast and automatically cast this as an animal, then only the animal information would be available. What is the problem? I cannot.
Yeah, there are some downsides there. In particular, if you have a classic case, if you have a graph with a generic node type of some sort. If you restrict casting of references, you wouldn't be able to somehow sort of pattern match on that and say, hey, this isn't a generic node, this is a integer node, or specifically a reference to one. You would have to do so and consume the AST or the graph and perhaps produce a new one in the process. So it's something where I'm not entirely sure of yet if it works out. And there also I'm not entirely sure yet if it's that important, in a sense that it's not that common, I think, to have a function that takes an array of animals and it deliberately pushes a dog in it.
Correct.
It's not common, but you have to do the test because people make mistakes and it's done.
Right, and that's the thing. Like I take a more, I would say, harsh approach. I would say, like, we don't test. If your program blows up, that's your fault. Like you wrote bad code, basically.
No, don't do that. That's the whole unsafe C thing all over again.
Not entirely. It depends on how you crash. Like if you just sort of silently continue.
No. Promptly I shove my dog into your cat. I do cat-like things on a dog. I've carefully arranged my dog such that when you do a cat-like thing, I can do whatever the hell I want, because cats can do things that dogs can't. And promptly I'm off reading the end of an array and sort of, I did a hack. I broke the JVM security model because of this kind of stupid shit. I had an outstanding bug with Sun for a decade where I had a 5-line program that broke security using essentially casting of an A to a B.
Right.
I cast A to B using an array of A's versus an array of B's and loader constraints on class loading and class files that you couldn't Java JIT, but you could compile them, rotate the Java out and compile again, merge the class files, and the loader constraints failed to pick up that you changed the class correctly. And I had an array of A's, an array of B's, and I put a B into an array of A, and I treated it like an A thing, and that was a security hole, and I could do anything I wanted. Peek and poke the universe from pure Java. as soon as you could break the security. So as soon as you could get an A into a B, it wasn't like it was a passive, just saying, it wasn't like it ran on until you crashed. It was, now I can read your process data directly.
Right.
If an A gets to an B, it's like bad.
Yeah, right. So promptly, you know, one of the two was a giant array of many gigabytes in size, and the other one was whatever, and they overlaid, and promptly your B object had a pointer to memory, which was the state of the entire heap. And I could now read the entire heap as an array of bytes and write it out to disk and do whatever the hell I wanted to it. And a little more cleverness from there, I could go to get the class pointers and do the same thing and pull up the class pointers. And now I have the structure of the heap as well as the contents of the heap. And it wasn't long after that where I could get the cut to the VM and everything else. So I stopped at that point and said, okay, you know, you're toast.
No, I think my point here is more that I think it comes down to this. Like, if you have to resort to a runtime type check, I think there's a better solution for that. Like, as in, take a step back and figure out, okay, how can we prevent this runtime type check that is probably only going to fail in like 1 in a million cases.
Right. It's a stupid check. I'm with you. I'm looking for the better answer where it doesn't need to be done.
The way that we do it is on widening conversions. We actually introduce a new preamble on the, if you're passing an array of animal to a function that takes an array of animal, it goes straight through. But if you're passing an array of cat to something that takes an array of animal, you actually have to give a different pointer, if you will. You can't just pass the same, because the widening conversion implies an additional preamble for each of the.
So what is the effect of the preamble on the runtime in the function that took an array of animal that happened to be cats?
It would be a runtime check, yeah. On store, it would be a runtime check, yeah.
Okay, and you're catching at the function call level as opposed to the array store point.
Well, so the question is so I can't answer that question because there are two different paths, right? So the one is that you're generating the code. So you could catch it you could actually have basically two productions of the same function, or you could build it into the V table of the collection object itself, in which case it becomes a runtime check on each iteration.
Right. Okay. I'm looking at, like, Java has it done at the time that you do a store.
Right. So the key is, though, to hide this goes back to the contracts discussion. You want the runtime to be able to make that choice. If it's a 1 in a million, then then you don't want to be doing the check on everyone. If it's 1 in 2, it's like, okay, it's fair to do the check on everyone.
Yeah. Okay. So the difference here is the effort to make it go fast versus saying I'm going to catch it at compile time.
Right. You can't catch. I would argue with our design, you can't catch it at compile time by design, right? So because you are allowed to pass to a widening conversion.
Yes, I'm not arguing that. I'm wondering if there is a way to say you cannot accidentally pass an array of cat to an array of animal where the guy who takes the array of animal promptly stores a dog. It's just not allowed by the language spec, as opposed to one that says I wrote this code, I ran this code, and it blew up when I made the call, or it blew up when I did this dog store into the array.
It will blow up either way when you do the dog store into the array.
Yes, but if you did it at the call, you stopped it sooner, which meant that if inside the guy, he happened to know that I'll also ask the question of this animal thing and then decide I won't ever shove a dog into this particular array because it misses some specialness.
Well, what our goal is if you're passing an array of animal in, you shouldn't pay a cost. If you're passing an array of dog in, you shouldn't pay a cost. You should only pay the cost if you're passing an array of cat in.
And you're storing dogs into this thing.
Right.
Yeah. And the cost is there's a runtime test and a blow up. And you're saying you can blow up at the function call boundary. And I'm claiming the guy who stores it.
No, I'm not claiming that. I'm claiming the opposite, which is when I pass an array of cat in, I need to change the thing that's going in so that it does the extra work and makes the person who's passing the array of cat in pay that cost.
Oh, you have a different target function, clone of the target function, which knows that happens to have in a cat because that's where you
So
specialize.
if you're smart enough to never actually put the dog in, if you happen to be passed an array of cat, then
Yeah.
you're good. And if you make the mistake of trying to put the dog in, then you blow up. And either way, you're paying the cost on each store.
Right, but
if you pass the array of animal in, you don't pay the cost. And if you pass an array of dog in, you don't pay the cost.
well, you have to be specialized for dog, but then you get a dog array storing a dog, and you can get rid of the test that way. You have code cloning going on, effectively.
Right.
So just so we're clear on the cost of the array store check, if the array store is happening over a loop, over an array, 9 times out of 10, 99 times out of 100, you can pull it ahead of the loop and you're done. So it's actually typically very cheap, but it's definitely, it can happen. So you have to deal, and there's a bunch of engineering, and it can happen so the language allows the user to make this mistake. So there's 2 costs: the engineering to go make it go fast when it's not failing, and the other cost is when it blew up, the guy who blew up wished it had blown up when he was at his IntelliJ and running it in the compiler, and it said Java C said no, instead of blowing
it would be
up
nice if it blew up 3 years earlier at compile
exactly.
time rather than in production.
You'd rather not. Yeah, you'd rather have it blow up earlier. And I'm looking for, is there a way to get it to blow up earlier? I hear what you said, Cameron. What I just heard is code specialization makes it cheaper, even cheaper. It's not very expensive. It's annoying. You can make it even cheaper. Okay, good.
So you say that if we have a store check, in most cases we can hoist it out of the loop.
Yeah.
But I imagine usually we store different instances into the same array. So how do you hoist it out when you need to type check against every individual instance?
You look to see if the first thing is you look to see if the array that you are storing is the names type of the array.
That's the preamble I'm talking about. So basically you have an upfront fork. You're like, am I ever going to need to check? Nope. Okay, go the fast route. Oh, I do have to check, go the slow route.
The C2 does that already, but it does it at the loop boundary. When he sees the store check showing up the loop, he throws the test in. And then and he'll do it as the earliest point of the upper bound of all the stores and decide I'll go faster. Because if that passes, then everything else gets wiped out of terms of tests and they're done. And that passes a lot. If that fails, then he has to delay the test until you actually do a store that's going to fail. And then if you have, there's another thing we can look at on the guy that where the objects are coming from that we can short on, and then we have to do what Arthur just said and actually test in the body of the loop.
So you're saying that you're using the static types available at compile time in order to prove it will never happen.
Yes, that covers a lot of cases.
You predicate the loop. Yeah, got it.
Yeah. But when that fails, we go down to checking it element by element.
So it's not quite hoisting the check out of the loop. It's predicating the loop with check which will imply every single check inside.
Yes.
So it's cloning the loop creation code.
We're not actually, actually C2 never cloned the code. Although we could do that. What we do is we do the test sort of manually, and upon a passing, we just accept that we will have that value and split the test in the code and write the one pass only. And we'll deop to the interpreter if we fail out. And if there's another variation where we give up that test is not going to pass, and then we go ahead and emit the test in the body and suck it up. The code cloning could be done by C2, but he doesn't. At the time I left Sun, and I don't know the since then, he doesn't do much cloning of loops based on if conversion. There were a few cases that happened, so maybe there's more now. The main one happened was NIO, direct byte buffer versus heap byte buffer. We did a lot of cloning on just those 2 instances.
Interesting.
Yeah, that was another one of these hand rules. Like someone was saying, Charlie was saying the string, I taught string to the GC, like I taught NIO byte buffer to the C2. And I did a generic code cloning hack, but the heuristics to not fail to endlessly clone and blow out your iCache are really dicey. So the heuristic when I left was, and if you are NIO, and if you're not NIO, bam, okay, loop clones. So somebody was doing it, so it was happening. Who's Roland? I don't know Roland. Except the guy, there's some Russian guy who's been there forever and a day who's actually pretty good, but his name's like Vladimir.
I think that JavaScript runtimes have a similar problem in that most of the JavaScript runtimes think that an array of ints is a thing, but JavaScript does not think that an array of ints is a thing.
Yeah.
So you're going along at really nice speed, and then suddenly someone's like, I'm going to stick a double into this list.
Yeah.
And it suddenly has to do the allocate some new memory. This is the new array that is less specific, and it's got a pointer to the old array. And every time you read from it, it moves the one you read plus a couple of others, and like tries to never wait to, because you don't want to do the whole copy when you're stuck in a double, because that's going to crush you.
Yeah, the Zool does this, the read barrier on a GC, right? This is a read barrier. And that the way it gets good concurrent, low latency, yada, yada, perfect every way, beats all of Sun's collectors by tenfold. Way it does it is does a read barrier. And that's exactly what we just said. We do a read barrier. Load the pointer up, do a test. Oh, it's been forwarded to the array of generic doubly things, a non-array event. All right, change the pointer, change where it came from, carry on. Technology works, but you pay a cost on every load, which you want to beat the hell out of that cost down. Yeah, that's fine. Yeah, JavaScript has more issues here because they have fewer hardwired types. And so they must just optimistically assume it's actually always going to be the good thing. And then it fails on them all the time. They have to have all the corner cases. Java can not do it mostly, only have to do it occasionally.
You'd be surprised how well an array of ints in JavaScript stays an array of ints for the lifetime of the object.
That could be. That could be.
But no guarantees.
Unless you're blowing out your overflow or something. Your 32-bit to 33-bit blew out, but you fit in 53, which was the double size. So maybe. I don't know. I did a lot of shit with JavaScript doing long milliseconds since the dawn of time, since the Unix epoch. And you know, we had a lot of issues with treating it. You couldn't be an int, so you had to be long. And I'm trying to say it flew over 53 bits. The exciting bits were more than 53. So you had to do something. I remember doing something magical and made him like believe it was actually 64 bits, and then he was happy. And I was happy I didn't get my timestamps chopped at 53 bits.
I think microseconds since epoch still fits in a float, but the
not in a float.
Nanoseconds does not. You start losing the low precision.
Right. Maybe there was some limit there. This was doing this fintech game. Oh, maybe that was it. I couldn't do nanos. Some of the exchanges reported nanos, and some do not.
And we just decided to go with picos and be done with it.
Well, you decided to go with 128 bits instead of 64,
right?
Which I didn't want to do.
Right. If you store the number of seconds since 1970 in a float, you have about half a microsecond of precision. And if you try to store nanos in there, things will no longer be equal because you'll lose pieces of the nanos.
Okay, yeah, I don't want to be half a second. I want to get millis was okay mostly. There were a few times when you wanted nanos, and we went back and forth on where they were going to deal or how we were going to deal. Most trades.
But yeah, storing time in a float is an interesting game.
Yeah.
Billion seconds is 30 years, right?
You can't do seconds now.
So
yes, a billion is about 30 years.
So
billion millis.
So 32
billion
seconds.
Oh, seconds.
So 32-bit would give you only 120 years in terms of seconds.
Yeah, but I have 1,000-fold more, so divide, and that's less than a year, and that's no good.
Right.
Yeah. So I'm using a long, but I was doing display stuff. So I was slopping milliseconds around to do the browser, doing big data exploration of stock trades. Right. So I had 1 million items in the browser memory, and he was trying to run out of memory, and they're all compressed. I'm doing the C2 compression hack in browser and blah, blah, blah. And then I slapped milliseconds around, and then they would run over. Something was running over, and I screwed around to make it fit in the browser. And I'm trying to remember now what the hell it was. This would be 2 to the 53 or 2 to the 52 milliseconds. And I don't know, that might fit. Nanos wouldn't, but millis would maybe. It's fine. I know I had to do something on the browser, but maybe it wasn't anything other than avoid nanos.
And you're running across that problem because the browsers don't have longs.
Yeah.
They just have floats.
Yeah, yeah. Well, and some dumbass trader was trying to do, what was the hell thing? What do they call it here? abusive trading is there's a technical term. What it means is he spammed the exchange with as many trades per second as he could that were all wash trades, so they cost him no money. But he slowed the exchange down by a handful, like some fractions of millis, so that he could get a front-running buddy to go do a trade somewhere else ahead of the market as a whole. Like this is Flash Boys style shit going on. So if you
That
look
can't
at
be legal.
trades per second, right? It's your intention. Well, you got to prove it. Yeah, this is. I did a startup on this shit. You got to prove it, right? Okay. Well, the intention is so somebody does 1,000 trades a second. That's pretty normal. That's okay. Somebody does 1,000 trades a millisecond. You can't count by the millisecond. You got to count by the nanos, and then validate that that's what's going on. And then you can come back and say, okay, this is somebody doing abusive trading. They are attempting to do something. And of course, the exchange slows down because it's just a computer, and it deals with the trades as they come in. And so somebody else got pushed out by 10 millis, however many. The guy, jams for a while. What's 10 millis mean? Well, 10 millis gets you from Chicago to New York. So somebody else then totally did a front running hack on you and dumped, and you got stuck holding the bag when you finally got your trade in and you lost. And the front running game is the guy who wins by 0.5 of 1%, and the guy who loses it all. It's a stupid, you have to have whatever. I can go down these trades if you want. There's some crazy games there, but you don't want to be number 2 in these trades. Fine.
Yeah, it's amazing what some people come up with.
Oh, yeah, totally. Oh my God. There's all kinds of shit. And the fun names, this is like 60s, 70s, 80s stock market traders, Chicago. I think Chicago bad boys. The names they have like Banging the Beehive. Banging the Beehive is putting, getting the market riled up to put volatility in the market because you have some stagnant, stale stock you're trying to unload. And if you unload it now, nobody wants to buy it. So you'll take a burning, you take a beating selling it at a low price. So you're just trying to get things to move. So you buy here and you sell there, and you buy here and you sell there, and you buy here and you sell there. All trades are roughly equal value. Nothing changes hands. No money changes hands, but stock moves. And you do it as fast, as hard as you can. And you've talked to 3 of your buddies across the street, and they're all in the same kind of boat. So they all do the same thing too. So it's collusion and banging the beehive, and the market gets all riled up. There's a bunch of volatility, and then you have a chance to do a short of this and a long of that, and suddenly you can dump your stock without taking a beating on it, right? And and then the market settles down. And why did that all happen? And what people look at what was going on that day, and there's nothing going on. And somebody else said, yeah, but I bought this piece of shit stock because I thought the market was doing this, and it wasn't. And then there's an intention for you to cause a disruption, that intention of selling something or whatever. And so that was declared illegal, and now proved that that's what happened. And it's kind of crazy shit. There's a lot of collusion things going on too. Prove that these 2 people didn't talk. Because if they talk, they might be colluding, and then they've agreed to screw around with the stock price behind your back to get a third person. So all communication between traders when they're actively trading is actively, heavily tracked with big laws about what you can and can't talk to whom about what. But of course,
that seems hard in the age of burner phones.
Oh my
text
God,
messages.
It's incredibly hard to prove anymore. Yeah, totally. Holy shit. So instead, you do shit like, I looked at the trades that all happened on this particular stock at this nanosecond in time, microsecond in time. And I looked and said that like these 3 guys rotated the stock between them, of course, over the span of a few, milliseconds, because we do know who the trader's associated back to. And if you're in the exchange, if you get the logs from both sides, you can track it all, and you can say, yeah, it went from da 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 da, and that's that's not legal.
You start making statistical arguments. What are the odds that all of these people who decided to trade on this day would have picked the same microsecond to do it?
Time, totally statistical argument, but it's a really strong one. So that one will float by a federal judge, and he'll smack somebody on the knuckles here. Say no 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 no. Fine. Yeah, it was a fun time. It was a good and a bad time. We had shit that worked for terms of tracking and finding fraud. And the CEO, nice kind of young kid, but he was not the right CEO. We had a product that worked. We had a market that was excited, and the CEO just dropped the fucking ball. Pissed me off. fine, whatever. Water under the bridge. But now I know a whole lot more about, how the markets work and, like sausage making. You kind of hope it tastes good and it's probably safe to eat, but boy, it's ugly. And there is, by the way,
if you think that's bad, you should see how they do ETFs.
Well, I do know how they do ETFs. No. I've been banging on that side of the things too.
Have you looked at the liquidity issues with them?
Oh my God, there's all kinds of stupid ass games people play with these things. I did commodities, I did futures and options, I did all kinds of shit. Oh my God.
May I know what does ETF do?
Exchange traded fund. It's a blend of top stocks that is, in theory, balanced and kept balanced by, say, cap table or the capital value of the top 500 or whoever, with the goal being that you're riding the high average value of all companies without somebody second guessing. So it's an algorithm guessing the mixture of stocks. So there's no guessing. You're just told this is the mix. And then the goal is you don't have a trader that's dicking with you or messing around or making bad trades or taking a fee. Like the fees on ETFs are super low because they just run an algorithm and they rebalance and they go. So the theory is it's a pretty stable way to get a steady, roughly equal to the market's year-over-year annualized return, which stock markets still annualized year-over-year, pretty damn good compared to everything else you can get.
Yeah, that's a little bit maybe a narrow view of ETFs. An ETF to me is kind of any company set up and then listed on an exchange. Like company can be comprised, it can buy the assets of, say, 15 companies in equal dollar amounts or whatever kind of plan they have, and then they sell. The company now is worth $1 billion. They sell the shares to the company. And that's it. There's, other than sending out annual reports and stuff, there's nothing happening. And so, yes, the costs can be really low and can be attractive.
And there's an algorithm deciding the blend.
Or none.
Somebody decides the blend. But
no, I mean, I can point you at some that I've invested in. They buy, 10,000 shares of each of these 15 stocks, and that's it. There is no adjustment ever.
Okay, well, that's your algorithm.
Yeah, so I said it's a simple algorithm. It doesn't cost anything to run, even somebody on pencil and paper.
What I'm claiming is a person making the choice of what to buy got pulled out of the loop.
Right. Yes.
But which I claim is still, that was part of what I said with ETF.
You don't have to pay anybody to do the rebalancing because it's not happening.
Yep.
Classic compiler trick. Run all the computation at build time. Then you're done.
Yeah. Print 42 and walk away. We did that. That's grad school. I did that. I did. A buddy of mine did that. We were trying to go run this code, optimize fastest, yada, yada, whatever. We had to go write an optimizer. This is grad student, second, third year grad student course. Go write an optimizer. And one of the guys turned in two. One of them was his real answer, and one of them was he just ran them all once, got the answer, and then printed the answer. So the Turbo 2000 or whatever, he had some funny name for it. Ran in one clock cycle for every one of them, printed the correct answer.
Do you have opinions for how you should give your users the ability to say, I would like this value to be known at compile time?
You say
like C++ has its const expr.
Yeah, static const final equals blah, blah, blah. That's not a great answer, but it's not a bad one. The problem with that answer is that you have to do the math and turn it into a thing, right? Whereas if I have a complicated set of arrangements, like in land of C, I use macros when I want to have a long series of things that are byte offsets within some fixed data structure or whatever. I'm memory mapping over UART, decoded receiver hardware bit or whatever. And I get them all to be compile time constants by having constant expressions that are nested piles of macro expansions that just turn into a wads of bits. Java does some amount of wads of bits folding at compile time and will get you that some ways, but it has more limits than the C macro expansion technology does.
Yeah, and C++ has come a long way as well. I mean, they'll now evaluate all
There's,
code basically. I mean, it's now capable of actually running the C++ code at compile time.
Yeah, I'd heard that. I had never done that, but I'd heard that you could do that now.
I was going to say, what happens in Java if I have some constant thing that I am trying to build and I like read off the disk?
You can in Java, and I have done this occasionally, throw it in a new class as a static final. You have to make a new class. You read it without this class existing yet, because constants in Java are compile time constant as soon as they become a static final in a class. So it's seal init time for any class.
So I could have something that reads a config file at runtime on the server, and if I declare it static constant final, it will now read the file on the machine that built it?
No. When you run the program, it reads the file at runtime. It makes a class object. You make a class object where you fill in the fields, the static init, seal init just reads from your dynamic structure into seal init fields, into static final fields. Now you have a class which has static final values with known things. The JIT will treat those as constants.
There's also constant dynamic that you can use. I think it was added in Java 11.
So then I don't know what constant dynamic is.
It lets you LDC.
These words seem to be contradicting each other.
Yes, exactly. Go ahead.
It's a loadable constant, so you can LDC something that you basically get to compute at runtime, and forever after it's stored in the constant pool, so the JIT can treat it as a constant.
I mean, that's exactly what I'm talking about. That's how those things get done. They get jammed into a constant pool. But you're saying there's some language nicer way to go do it.
There's a bytecode nicer way to do it, but
there's
no
a
language way to
bytecode got added for this?
They added a new constant pool entry. It uses the LDC bytecode. It's morally the equivalent of.
It's like the invoke. It's like invoke dynamic for static final fields. Yeah.
Okay. Fine. Yeah, interesting.
There's also some work that Sean Baxter is doing in Circle/C++ that I find kind of interesting. The language is designed so that you use the same constructs to describe things that become constants after the compiler is done. And so some of the stuff runs at compile time. It's kind of analogous to your buddies that were doing the optimization and just printing the results. Well, that's the job of the compiler.
Yeah, right. Yeah. This is all what that's about. It's go compute, jam the value in. Now the next generation, the JIT happens afterwards, uses the prior thing as a constant. And constant folds away. Yeah.
But in Circle, you could just express the algorithm that you want to compute. It gets computed at compile time, and then when you run the program, it's the 2 cycles to here's the answer.
Right. Okay. Yeah, fine. There's a theory that says there's a JIT technology which does all that automatically behind your back for you, which is slow moving fields. They got set once. They've never been set since. I'll intercept all set points and blow out and re-JIT as needed. Otherwise, I'll treat the contents of the field as a constant until it gets changed. And a whole lot of
adaptive compilers are pretty powerful.
I'm sorry?
Adaptive compilers.
Oh yeah,
you
get to do all kinds of shit. Yeah, that's a good way to go. Constant dynamic. Yeah, that's a funny name. All right, it's noon. I've been here 2 hours. For everyone who came really late, daylight savings time happened to me. So I put PDT, not PST, on the timestamp. So check your hours about what time 10 o'clock in California is.
Next time we will be on time.
Yeah, it's okay. I started up and like 5 people, like, aw. And then 6, 7, 8, and then right at the 11 o'clock mark, like 6 more showed up. Like, wow. All good. All right. Next week.
Thanks, Cliff.
Bye.
Thank you. You guys.